last step is deleting the first row. And we have -1, 3, 0, 2, 6, 1, 3, 9, 0. And that's all. I'm going to talk a bit more about transpose matrices because I'm going to need it to invert matrices. I'm going to need them. So remember, transpose matrices is the matrix I obtain inverting row and columns in the matrix. And if a matrix has a dimension Milan by Naples, the transpose has dimension Naples by Milan. A few useful property of transpose matrices. If I transpose twice the same matrices, I obtain the initial matrix. The transposition of the transposition of A is A itself. This transposition of the sum of two matrices is the sum of the transposition of the matrices, and the transposition of the product of the matrices is the transposition of the second matrix times the transposition of the first matrix. Remember, only when I can multiply the two matrices. Remember that in general, a note here. Note, in general, A, B is different from B, A, which is there is no reason why the transposition of B times the transposition of A should be equal to the transposition of A times the transposition of B. Even more, it may be the case that multiplying, well, the transposition of A and the transposition of B doesn't make any sense. Remember that we can multiply a matrix and another matrix only when the number of the column of the first equals the number of the rows of the second, which is and this is not always, and this is not in general satisfied by ATBT, unless both A and B are square matrices, meaning have the same number of rows and of columns. In particular, at the beginning, when and if multiplying two matrices, be careful about whether you can perform this operation. So let's solve the following example. Well, let's solve the following equation. It's actually a system. So we have some system defined by this equation, A times BT plus X equals C. First of all, if this system has a solution, you can rewrite this system as X equal C minus A B T. I'm subtracting A B T from both sides of the equation. The same way we do this number. So multiplication of matrices is different from multiplication with simple number. But summing matrices has exactly the same properties as summing numbers. So let's check whether A BT makes sense. So A is a 3 by 2 matrix. B is a 3 by 2 matrix. So A B T is a 2 by 3 matrix. So ABT is well defined. So let's solve this problem on a new. Let me check whether. Okay, here. Let's copy. Paste. Can you read it? Yes. Can you read it here? It's big enough. I can. So let me do the following. So X equals C minus ABT. Remember, X equals C minus ABT. So BT is, here you have A11 of BT stays A11. 2. A1, 2 of B get to be A2, 1 of B. So we have 0. A 1, A2, 1 of BT of B is A1, 2 of BT minus 1. Then A 2, 2 of BT of B stays A2, 2 of BT. So here it's 3. Then